All right, let's talk real quickly about naming ionic compounds. Naming ionic compounds is really, really simple. All you do is you write the name of the metal ion first, then you write the name of the nonmetal ion, but you change the last syllable of its name to IDE. For example, our good friend table salt. We write the name of the metal first, sodium. Then we change chlorine to chloride. Notice how nowhere in this instructions does it ever say for us to worry about numbers. In other words, if I wanted to name this compound, I wouldn't tell people that that 2 is there. I would simply name it by writing the metal, calcium, then writing the name of the nonmetal, fluorine, with the suffix -ide. So fluorine would become fluoride, so it would be calcium fluoride. Chemistry is easy, life is hard, yes? Why doesn't everybody write down Truman? Everybody write down Truman. All right, let's write the names for the following compounds. Remember, we don't need to worry about numbers. All we're doing is writing the name of the first element and then changing the last element so that it ends in the suffix -ide. So, our metal is calcium. Our nonmetal is oxygen, so we're going to change oxygen to oxide. Our metal here is potassium. And you can use a periodic chart for this, right? You should have a periodic chart printed out so that you can look at it. Then our nonmetal here is bromine, and bromine is going to become Barney Stinson's favorite element, bromide. The only element mentioned in the Bro code. Our metal here is aluminum. Our nonmetal is oxygen, so oxygen becomes oxide. Metal is magnesium. Our nonmetal is chlorine, and chlorine becomes chloride. Chemistry is easy, life is hard, yes? Here's another learning check. And basically in this learning check, we're going to figure out what compound sodium and bromine can make, sodium and sulfide can make, and sodium and nitride can make. Then we're going to do the same process for aluminum bromide, aluminum sulfide, and aluminum nitride. Pause me and try it yourself. I know you don't want to pause me, you just want to get the lecture over with, but try it yourself, seriously. Did you try it yourself? Oh, you thought I was only telling seriously to try it himself. Ha ha! Oldest one in the book. Stop calling me Shirley. All right. Let's take a look here. Sodium's +1, bromine's -1. So the charges cancel out. Sodium +1, sulfur 2 negative, crisscross, 2 down there, 1 there. Sodium and nitrogen. Sodium +1, nitrogen 3 negative, crisscross it. Sodium 3, nitrogen. Now let's do it again with aluminum. Aluminum 3 plus, bromine -1, crisscross, so that we have 1 aluminum and 3 bromines. Aluminum 3 plus, sulfur 2 negative. We crisscross. The 2 on the sulfur becomes the number of aluminums. The 3 on the aluminum becomes the number of the sulfurs. Here's the tricky one, though. This is actually the most difficult one on the page, is the last one. Aluminum 3 plus, nitrogen 3 negative. If you crisscrossed, you'd get 3 aluminum and 3 nitrogens. Remember that the formula for an ionic compound is supposed to be a ratio in lowest terms. Can you divide something, 3 and 3, by something other than 1? Yeah, you can divide it by 3. So you're not in lowest terms there. Also, if you're crisscrossing there, you're overthinking it. Remember, our goal is to get the charges to cancel out. We want the charges to cancel out. So if I have a positive 3, then it's canceled out by a negative 3. So my ratio here is 1 to 1. That's it. Chemistry's easy. Life is hard. Life is especially hard if you were President Polk. Everybody write down Polk. P-O-L-K. Not all ions consist of just one atom. Sometimes a group of atoms can develop an extra electron, or a group of atoms can lose an electron between them and share the burden of caring for the extra electron, or share the hardship of going without an electron. When a group of atoms develop a charge, that group of atoms is referred to as a polyatomic ion. A polyatomic ion is a group of atoms that has a charge and functions just like it's a single unit. These polyatomic ions have special names. I'm not going to make you memorize those names. You just need to recognize clues that you have a polyatomic ion. And most of those clues that you have a polyatomic ion, you'll be looking at a chemical formula, and you'll notice it ends in something other than IDE. Let's take out carbonate, for example. Carbonate, CO3, 2 negative. Just to make sure we're clear on what we're looking at, carbonate is 1 carbon and 3 oxygens. The group of them together has adopted 2 extra electrons from somewhere. And that whole unit has a charge of 2 negative. Not the oxygens or not the carbon, but the whole unit has a charge of 2 negative. In order to do your homework, I would recommend printing out this slide full page and having it handy when you look at things on the computer. It'll just make life easier. These are a list of several different polyatomic ions and their names. We will use these names to help us name some ionic compounds that contain these polyatomic ions. Now, if some of you had to memorize these in high school, then you'll probably recognize the following song.